Welcome back to this class on measures of central tendency. In the previous part, we learnt about arithmetic mean, and in this part, let us understand median and mode. As we have learnt in the previous presentation, measures of central tendency can be done in three different ways: mean, median, and mode. Data is collected in three different ways: simple series, discrete series, continuous series. Median is usually defined as that value which divides the distribution so that an equal number of items occur on either side of the median. There are 50% of the values are greater than the median, 50% of the values of observations are smaller than the median. Median is the middle value. If there are odd number, the central two values are added and their average is taken. So we have the observations here: 70, 84, 86, 99, 103. The median for this is 86. It's a simple observation. But calculation of the median can be done by finding the size of the n plus 1 by 2th item. I'll repeat, size of n plus 1 by 2th item. That is where the median is. So we have a simple problem here. The first thing that we should do is we should arrange the data in either ascending or descending order of magnitude. I have arranged the data in the ascending order, as you can see here. After arranging, I must find the size of n plus 1 by 2th item. N is the number of observations. Suppose if you have 9 observations, 9 plus 1 by 2, that is 10 by 2, that is the 5th item. 5th item here is the median. And these are the steps involved in the calculation of median in a discrete series. First you must arrange them in the ascending or descending order, calculate cumulative frequency, find the size of n plus 1 by 2th item. Median lies, you can see where the median is lying. Alright, I have arranged them in the ascending order of magnitude. The number of plants, that is the frequency we have to calculate the cumulative frequency by adding up the values diagonally. You can see 22, you can directly add it. Next is 25 and 22 are added to make it 47. 47 you get by adding 25 and 22. Similarly, 33 and 47 are added, you get 80. 40, 80 are added, 120. 47, 120, 167. 50, 167, 206. 42, 206, 256. Like this, you have to add the values diagonally and you will get the cumulative frequency. The last value, 400 in this table, is what is the cumulative frequency. Alright, and for calculating median, you need to have the cumulative frequency and use the formula m is equal to n plus 1 by 2th item. So you get the median value. So you get the median value. So here median, the value that you give is 200.5, that is not available. The next higher value is 206. We must always consider the value that is next higher, and the value corresponding to that is 12. So thus 12 is the median. So 206 is not the median, 12 is the median, the value corresponding to the n plus 1 by 2th item. Now similarly you can calculate in a continuous series. The formula is different here. Median is equal to L plus n by 2 minus Cf into I divided by F. I have given the description of each and every letter in the formula. You can read it once again by rewinding the video. So we have the different classes, we have different frequencies. Similarly, you have to calculate the cumulative frequency by adding up diagonally. So you can see I'm marking diagonally. 13 into 2, 13 plus 283 is 296, and you get 300 is the cumulative frequency. Divided it by 2, n plus 1 by 1, n plus 1 by 2. So in this case, there is no n plus 1, it's n by 2th item. So you get the class, median class 20 to 25 is the median class. Alright, so you get the median class and use the formula. Use the formula L plus n by 2 minus TF into I divided by F. So you get your median. Median is 22.92. Calculate the median in an unequal class interval when the classes are not equal. Classes need not be equal. 0 to 10 is the first class where the difference is 10. 10 to 30 is the second class where the difference is 20. 30 to 60 the third class where the difference is 30. So the classes need not be equal. It does not matter. Even the classes are not equal, it does not matter. We can use the same formula. Similarly, we also can use the same formula even in the open-ended classes. What are open-ended classes? Where the lower value, higher value are not known. Let us look into mode. Mode is derived from a Latin word called la mode. La mode means fashion. Mode is another measure where it is the most fashionable typical value of a distribution because it is repeated highest number of times in a series. The mode is the most commonly occurring value. Mode of a distribution is the value at the point where the distribution is maximum. We can calculate mode by different methods. The mode can be single mode, unimodal. Mode can be there may be two modes. In that case, it is called bimodal. There may be three modes. It is called multimodal. So mode is the most commonly occurring value. So in the first example, 10 is the mode because 10 is repeated twice. In the second example also, we have 11 is the mode because and 10 also is the mode where 10 and 11 both are repeated. Alright. So in the third case, there is no one which is mode, but what we can do is two central values can be added. Their average is taken as the mode. So calculation of mode, we have to put the data observations in tables, values and frequencies. Wherever the frequency is highest, that is considered as mode. So in this table you can see 10, the value 10, observation 10 has 60 frequency, that is the mode. And the mode can be calculated by one more method called grouping method. And in the grouping method, we have to have different columns, 6 columns, and each columns you have to make the entry of data as explained in the slide here. You carefully go through the slide and construct this table. So you have to have 6 columns plus 1 column for variables. Column number 1, we are entering all the variables. Alright, and the remaining 6 columns. In column number 1, you are marking the highest value. Alright, so 30 is the highest frequency, and thus 10 is automatically mode, but it can be different. And column number 2, you are adding the first two values, 15 and 20, you get 35. And then next you are adding two more values, that is 25 and 27, you get 52. Similarly, follow the instructions and fill this table, and in each column circle the highest value. I have circled the highest value. So highest value, the high values in each column are shown here in the red color. Alright, and these red colors are later used in this next step in the scoring table. So we have columns here, alright, 6 columns, and we have the variables in the row there, 2, 4, 6, 8 up to 20. Alright, and we have to do the scoring. Scoring is done by the contribution of each column in giving rise to the highest value. So to make up the highest value, which columns, which frequencies are representing highest number. For example, in column number 1, 30 is the highest value. It is contributed by 10. 10 gets 1 point. Okay, so similarly, for each variable, what is the contribution of each variable in giving rise to the highest value, and that is what is calculated. And whichever variable gets highest number in the grouping table, in this case 5 is getting the highest number, and that is called the mode. See, in the direct method we obtain 10 as the mode, but by grouping method we obtain 8 as the mode. Thank you very much for watching this presentation on median and mode, and I hope you have understood measures of central tendency. Thank you very much.